In the world of cutting-edge manufacturing, the lowly ball bearing gets forgotten. Yet just about every machine part needs ball bearings to rotate. They're in household appliances, industrial machines, and even car engines. This is what's called a deep groove radial ball bearing. It has steel balls that move inside tracks called raceways, which are carved into a set of heavy-duty steel rings. The balls are made of the same type of steel. First, the shape and thickness of the rings is prepared. The inner ring is inserted into the outer ring. The pair then passes through a grinder that alters the width to the correct thickness. A gauge checks the width of each ring as it exits. Next, the inner and outer rings are separated in order to grind their outer circumference on separate machines. The outer ring enters the grinder, which shapes its outer surface to a precise roundness and diameter. Lubricants keep the ring from overheating, which would cause warping. The ring exits the grinder through a gauge that checks the diameter. Next, the outer ring's raceway goes for grinding. Abrasive stone wheels with an oil coolant shape the surface to precisely the correct size. The inner ring and raceway go through a similar machine. Now the rings go for polishing. An abrasive stone lubricated with oil polishes the steel surface. Here's the before and after. Next stop is washing. The rings are coated with thick oil and fine stone grit. The raceways are cleaned with kerosene. Elsewhere in the plant, the ball bearings, which start out as steel wire, are being created. The wire is cut into pieces and a die punches those pieces into rough balls. The rough balls go into a grinder, which removes the bumps. Then other machines round them out and give them a mirror finish. This entire process takes 2 days. The balls then go through a furnace to harden and then into a bath of cleaning solvent. After several quality checks, the finished balls go into hoppers. The hoppers are then loaded onto the automatic assembly machine. The ball feeder sends balls down through tubes to a ball pusher that feeds the correct quantity of balls into the raceways of the now reassembled inner and outer rings. A ball divider positions the balls evenly around the raceways. Next comes the ball cage, a metal structure that keeps the balls in position around the raceways. The first machine installs half of the cage, the half with rivet holes. The next machine positions the other half of the cage, the half with rivets. The machine test spins the bearing, then rivets the 2 halves of the ball cage together. The bearing is now fully assembled. Next, it goes into a solvent bath, then for a series of automated quality control tests. This noise vibration tester makes sure that the ball bearing operates quietly. Some types of bearings are lubricated with grease. A machine squirts grease evenly into the bearing's raceways, then inserts a rubber seal to contain the grease. An automated scale tosses out any suspect bearings that aren't the required weight. This unsung hero of the manufacturing world is the essential ingredient of any machine with moving parts.